You've been looking at Venus your whole life without really knowing what it is. That bright point at sunset feels calm, familiar, even harmless. For centuries, people called it the morning star, the evening star, something beautiful. And for a long time, that illusion held. We imagined oceans, jungles, maybe even another Earth beneath those clouds. But Venus isn't hiding a second Earth. From a distance, it still looks soft, peaceful. Up close, it's the opposite. Heat strong enough to melt metal. Air so dense it crushes from every direction. Clouds made of acid drifting over a surface that nothing we know could survive. This isn't Earth's twin. It only looks like it from far away. Up close, nothing about it feels familiar. Once you stop seeing Venus as just a bright point, the first thing that stands out is how close it actually is. At about 108 million kilometers from the Sun, it sits just inside Earth's orbit, and at times it becomes our closest planetary neighbor. That's why it appears so bright, especially around sunrise or sunset. And when you notice it, something feels different. It doesn't flicker like stars. It stays steady, almost too steady. For a long time, that made it feel less like a distant world and more like a fixed light in the sky. But that idea starts to fall apart when you look at how it actually moves. Venus rotates in the opposite direction of most planets, and extremely slowly. One full rotation takes 243 Earth days, longer than its entire year. On the surface, the sun wouldn't rise and set the way we're used to. It would move so slowly that a full cycle would take months. In practice, though, those conditions leave no real way to experience it directly. The atmosphere alone changes everything, dense, mostly carbon dioxide with surface pressure about 92 times stronger than Earth's. And the temperature doesn't just spike, it stays locked at around 462 degrees Celsius, almost everywhere, all the time. This isn't just a hotter Earth. The heat doesn't escape. It builds up and stays there, creating a permanent greenhouse effect. Above it all, thick clouds of sulfuric acid reflect sunlight while trapping heat below, sealing the planet off. For a long time, they hid the surface completely. It wasn't until spacecraft started sending back fragments of data, brief glimpses, that a clearer picture began to form. An Earth-like world never showed up beneath those clouds. What's there turned out to be far more extreme. That picture starts to change when we get closer to the surface. For a long time, Venus was completely hidden. The clouds didn't just blur details, they blocked everything. No direct view, just a bright, opaque layer. So the only way to understand it was to go through it. That's where the Venera program comes in. The probes sent in the 1960s and 70s were built with very limited operating time in mind. Some didn't make it through the descent. Others lasted only minutes after landing. A few managed to transmit data from the surface. What they found wasn't anything familiar. Extreme heat, crushing pressure, and a dense atmosphere that scatters light in every direction. Even so, they sent back measurements and a few rough images before failing. That was enough to confirm the surface wasn't just theoretically hostile. It actively destroys anything that reaches it. Later missions used radar to map the terrain. The result wasn't random. Large lava plains, widespread resurfacing, and structures stretching across vast distances. It began to look less like a planet with volcanoes and more like one shaped by them. And from that point on, Venus stopped being just an unknown. Once radar mapping became possible, especially with missions like the Magellan, Venus stopped being a blank, featureless sphere and started to resolve into something far more structured, even if that structure didn't resemble anything we were used to seeing. The surface, as it turned out, is overwhelmingly shaped by volcanism, not in the scattered regional way we see on Earth, but on a scale that feels more systemic. Vast lava plains stretch across most of the planet, covering roughly 80% of it, and they don't look like they formed gradually. They look like they were laid down in broad, sweeping phases, as if the surface had been repeatedly reset rather than continuously evolved. At the same time, something equally important is missing. There's no clear evidence of plate tectonics on Venus, no moving continents, no subduction zones, no slow recycling of crust. That absence changes everything about how the planet handles heat. On Earth, tectonics constantly releases internal heat in different regions. Venus doesn't seem to have that mechanism, so heat builds up instead of being steadily vented. When it finally breaks through, it does so on a massive scale. Large parts of the surface appear to have been flooded with lava, covering older terrain and effectively resetting it rather than adding to it over time. That also explains the crater record. With only about 900 craters and no clear layering between them, Venus doesn't show a gradual accumulation of history. It looks more like a surface that was cleared and then reshaped again. Even the craters themselves tell a part of the story. Smaller impacts are almost completely absent, not because they never happened, but because the atmosphere is dense enough to break apart or burn up smaller objects before they reach the ground. What's left are the larger impacts, events strong enough to punch through that barrier. So the surface we see today is shaped by a limited set of forces, large impacts that manage to reach it, and volcanic processes that have the ability to overwrite almost everything else. There's very little in between, and almost nothing delicate. What that leaves behind isn't a detailed timeline. It's more like a surface that has been revised multiple times, with older versions removed rather than preserved. You don't get a gradual story, you get fragments, separated by long gaps where the record simply doesn't exist anymore. And once that pattern becomes clear, Venus stops looking like a variation of Earth and starts to feel like a completely different kind of system. Not one that changes continuously in small ways, but one that holds onto its internal pressure for long periods and then releases it in ways that reshape the entire planet at once. Venus ends up being one of those places that looks simple from a distance, but gets harder to understand the closer you look. A bright point in the sky turns into a world of crushing pressure, extreme heat, and a surface that seems to have been reset more than once. Nothing about it really behaves the way you'd expect from something so similar to Earth in size. And maybe that's the part that makes it interesting. Because Venus isn't just another planet we observe from afar, it's a reminder that similarity on paper doesn't always mean similarity in reality. There's still a lot we don't fully understand about it, and that's exactly why it keeps coming back into focus every time we improve our tools and look a little deeper. If you enjoyed this, feel free to like the video. It really helps more than you think. And if you're into deep space topics like this, consider subscribing, because there's a lot more out there that looks simple at first, until you actually take a closer look.